If you're preparing for the Microsoft AI-300 exam, operationalizing machine learning and generative AI solutions, don't book your test before watching this. This is one of Microsoft's newest and most advanced certifications. In this video, I'm covering 20 exam-style practice questions with full explanations, built around the 5 official Microsoft Operationalizing Machine Learning and Generative AI Solutions exam domains: MLOps infrastructure, ML model lifecycle, GenAIOps, AI quality assurance, and performance optimization. Download AI-300 practice question PDF from Study 4 exam link is in the description. Let's get into the questions right now. Question 1: Which Azure service is the primary platform for managing the full machine learning lifecycle, including training, deployment, and monitoring, in the AI-300 exam context? A. Azure Databricks. B. Azure Machine Learning. C. Azure Functions. D. Azure Kubernetes Service. Correct answer: B. Azure Machine Learning. Explanation: Azure Machine Learning, AML, is the core platform for the AI-300 exam. It provides the complete infrastructure for training, registering, deploying, and monitoring ML models in production, the foundation of everything MLOps related you'll be tested on. Question 2: What is the purpose of MLflow in an Azure machine learning environment? A. Deploy Kubernetes clusters for model serving. B. Track experiments, log metrics, register models, and manage the ML lifecycle. C. Create infrastructure templates using Bicep. D. Monitor network traffic between Azure services. Correct answer: B. Track experiments, log metrics, register models, and manage the ML lifecycle. Explanation: MLflow is an open-source platform integrated with Azure Machine Learning. It tracks experiment runs, logs parameters and metrics, stores artifacts, and manages the model registry. Understanding MLflow is critical for the AI-300 exam's ML lifecycle and operations domain. Question 3: A team wants to automate model retraining every time new data arrives in Azure Blob Storage. Which tool should they use to trigger the pipeline automatically? A. Azure Logic Apps. B. GitHub Actions with Azure ML Pipeline Triggers. C. Azure Functions with Manual Runs. D. Azure DevTest Labs. Correct answer: B. GitHub Actions with Azure ML Pipeline Triggers. Explanation: GitHub Actions is the CI/CD tool heavily featured in the AI-300 exam. You can configure GitHub Actions workflows to trigger Azure Machine Learning pipelines automatically based on events, like new data uploads, enabling automated retraining pipelines without manual intervention. The Operationalizing Machine Learning and Generative AI Solutions exam is not just about AI, it's about production engineering. 3 infrastructure tools you must know cold: GitHub Actions, CI/CD automation for model training and deployment pipelines. Bicep, infrastructure as code to provision Azure ML workspaces, endpoints, and networking. Azure CLI, as ML extension. Command line operations for ML resources. If a question asks about automating or provisioning, think GitHub Actions plus Bicep. These show up constantly. Question 4: What does model drift refer to in a production machine learning system? A. The model file getting corrupted during deployment. B. A degradation in model performance because real-world data has changed from training data. C. A network latency issue between the model endpoint and clients. D. The model consuming more memory than allocated. Correct answer: B. A degradation in model performance because real-world data has changed from training data. Explanation: model drift, also called data drift or concept drift, occurs when the statistical properties of real-world input data shift over time compared to the training data, causing model predictions to become less accurate. Detecting and responding to drift is a core MLOps responsibility tested heavily in AI-300. Question 5: Which Azure Machine Learning feature is used to monitor a deployed model for data drift and trigger alerts? A. Azure Monitor Logs. B. Azure ML Dataset Monitors, Model Monitoring. C. Azure Defender for Cloud. D. Azure Policy. Correct answer: B. Azure ML Dataset Monitors, Model Monitoring. Explanation: Azure Machine Learning's built-in model monitoring capability continuously compares incoming production data against a baseline, usually training data, to detect data drift, feature distribution changes, and prediction drift. It can trigger alerts and automatic retraining pipelines when drift thresholds are exceeded. Question 6. Which deployment strategy allows you to route a small percentage of traffic to a new model version while the old version continues serving most requests, minimizing risk during updates? A. Batch deployment. B. Blue, green deployment. C. Canary deployment. D. Rolling restart. Correct answer. C. Canary deployment. Explanation. A canary deployment gradually routes a small percentage of live traffic, for example, 5 to 10%, to the new model version. If metrics look good, traffic is incrementally increased. This minimizes the blast radius of a bad model release. Azure ML Online endpoints support traffic splitting natively for this pattern. Question 7. What is the purpose of an Azure Machine Learning Managed Online Endpoint? A. Store and version training datasets. B. Provide a real-time REST API endpoint for model inference with managed infrastructure. C. Schedule batch scoring jobs. D. Monitor CI/CD pipeline runs. Correct answer. B. Provide a real-time REST API endpoint for model inference with managed infrastructure. Explanation. Azure ML Managed Online Endpoints let you deploy models as production-grade REST APIs with Microsoft managing the underlying compute infrastructure, autoscaling, load balancing, and availability. They support multiple deployments under one endpoint, enabling canary and blue-green strategies. The Operationalizing Machine Learning and Generative AI Solutions exam will test you on when to use online versus batch endpoints. Here's the simple rule. Anytime you see real-time or low latency, right pointing arrow online. Anytime you see large dataset or scheduled scoring, right pointing arrow batch. Don't mix these up. Question 8. What is Microsoft Foundry, Azure AI Foundry, used for in the context of the AI-300 exam? A. Provision virtual machines for data science teams. B. Deploy, manage, and operationalize generative AI applications and AI agents at enterprise scale. C. Store training datasets in a data lake. D. Configure network firewalls for Azure resources. Correct answer. B. Deploy, manage, and operationalize generative AI applications and AI agents at enterprise scale. Explanation. Microsoft Foundry, Azure AI Foundry, is the platform for building and operationalizing GenAI applications, including deploying foundation models, managing prompts, running evaluations, and publishing AI agents. It is a central pillar of the GenAIOps domain in the AI-300 exam. Question 9. Which practice in GenAIOps is equivalent to version control for code but applied to prompts used in generative AI applications? A. Prompt caching. B. Prompt versioning and source control management. C. Context window compression. D. Tokenization logging. Correct answer. B. Prompt versioning and source control management. Explanation. Just like code, prompts used in GenAI applications must be versioned, reviewed, and tracked. Prompt versioning, storing prompts in source control, like Git, alongside their performance metrics, ensures reproducibility, rollback capability, and auditability of GenAI behavior changes. This is explicitly tested in AI-300. Question 10. What does groundedness measure when evaluating a generative AI application? A. How fast the model generates a response. B. How well the model's response is factually supported by the provided source documents. C. Whether the model response is grammatically correct. D. The total number of tokens used per response. Correct answer. B. How well the model's response is factually supported by the provided source documents. Explanation. Groundedness is a quality metric in GenAI evaluation that measures whether the model's output is actually supported by the retrieved context or source documents, rather than being hallucinated. High groundedness means the model stays grounded in the provided data. It's one of the most important evaluation metrics in the AI-300 exam. Question 11. A company deploys a RAG-based application where answers are sometimes inaccurate. Which component should be optimized first to improve answer accuracy? A. Increase the model's temperature setting. B. Optimize the retrieval step, improve chunking strategy and embedding model selection. C. Reduce the max token limit on responses. D. Switch from Azure OpenAI to a local model. Correct answer. B. Optimize the retrieval step, improve chunking strategy and embedding model selection. Explanation. In a RAG pipeline, the most common cause of inaccurate answers is poor retrieval. The wrong chunks are being passed to the model. Optimizing chunking, size, overlap, strategy, improving the embedding model, and tuning the vector search index typically has the biggest impact on answer quality before touching the generative model itself. Question 12. What is the purpose of using Bicep for MLOps infrastructure provisioning? A. Train machine learning models faster using GPU acceleration. B. Define Azure infrastructure as code for repeatable, version-controlled deployments. C. Monitor model predictions in real time. D. Schedule automated dataset labeling jobs. Correct answer. B. Define Azure infrastructure as code for repeatable, version-controlled deployments. Explanation. Bicep is Microsoft's infrastructure as code, IAC, language for Azure. In MLOps, Bicep is used to provision ML workspaces, compute clusters, private endpoints, storage accounts, and networking in a consistent, automated, and version-controlled way, eliminating manual portal configuration. AI-300 expects you to understand IAC in the context of MLOps infrastructure design. Question 13. Which Azure Machine Learning compute type is most cost-efficient for running automated model retraining pipelines that don't require always-on resources? A. Dedicated compute instance, always running. B. Azure Kubernetes Service Cluster. C. Compute cluster that scales to 0 when idle. D. Azure Virtual Desktop. Correct answer. C. Compute cluster that scales to 0 when idle. Explanation. Azure ML compute clusters automatically scale up when a job starts and scale back to 0 nodes when idle. For scheduled or event-triggered retraining pipelines, this provides significant cost savings compared to always-on compute instances, since you only pay when training is actually running. Question 14. What is the primary role of MLflow in Azure AI Foundry for GenAIOps? A. Monitor GPU utilization on Azure VMs. B. Build, test, debug, evaluate, and deploy LLM-based application flows as production pipelines. C. Configure private DNS zones for Azure services. D. Manage API rate limits for Azure OpenAI. Correct answer. B. Build, test, debug, evaluate, and deploy LLM-based application flows as production pipelines. Explanation. MLflow in Azure AI Foundry is a development tool for building end-to-end LLM application pipelines, connecting prompts, Python functions, and tools into visual or code-based flows. It supports evaluation runs, C/CD integration, and deployment to managed endpoints, making it the primary GenAIOps development and operationalization tool in AI-300. Question 15. A model deployed in production starts making increasingly poor predictions 3 months after deployment. No code changes were made. What is the most likely cause? A. The Azure ML workspace was upgraded. B. Data drift. The distribution of real-world input data has shifted from the training data. C. The GitHub Actions workflow was modified. D. The model endpoint was restarted. Correct answer. B. Data drift. The distribution of real-world input data has shifted from the training data. Explanation. When a model degrades over time without any code or configuration changes, data drift is the most likely culprit. As the world changes, real-world data patterns shift away from what the model was trained on. This is why continuous monitoring and automated drift detection are core MLOps practices, and core AI-300 exam topics. Question 16. Which metric would you use to evaluate whether a fine-tuned generative AI model has improved compared to the base model? A. CPU utilization during inference. B. Evaluation scores on a held-out test dataset using metrics like groundedness, relevance, and similarity. C. The number of tokens in the training dataset. D. The time it took to complete fine-tuning. Correct answer. B. Evaluation scores on a held-out test dataset using metrics like groundedness, relevance, and similarity. Explanation. After fine-tuning, the model must be evaluated on a held-out test set using quality metrics, groundedness, relevance, coherence, and similarity, to confirm it actually performs better than the base model on your target task. Simply completing fine-tuning doesn't guarantee improvement. Evaluation gates determine whether the fine-tuned model gets promoted to production. Question 17. What does responsible AI observability mean in the context of a production GenAI application? A. Reducing the cost of model inference by batching requests. B. Continuously monitoring model outputs for harmful content, bias, and safety violations in real time. C. Logging all API request timestamps. D. Ensuring the model runs on dedicated hardware. Correct answer. B. Continuously monitoring model outputs for harmful content, bias, and safety violations in real-time. Explanation. Responsible AI observability means establishing monitoring pipelines that continuously evaluate live model outputs for safety and fairness, detecting hate speech, harmful content, hallucinations, and bias patterns at scale. In AI-300, this is framed as a production requirement, not just a development time concern. Question 18. An ML team wants to ensure that only approved model versions are deployed to production. What is the recommended approach? A. Manually review models in the Azure portal before each release. B. Implement a model approval gate in the CI/CD pipeline using GitHub Actions with required reviewers. C. Use Azure policy to block all model deployments by default. D. Store models in Azure Blob Storage without registration. Correct answer. B. Implement a model approval gate in the CI/CD pipeline using GitHub Actions with required reviewers. Explanation. In mature MLOps pipelines, human approval gates are enforced in the CI/CD workflow, typically as a GitHub Actions environment protection rule with required reviewers. Before a model can be deployed to production, it must pass automated evaluation checks and receive explicit approval from a designated reviewer. This combines automation with governance. Question 19. What is synthetic data generation used for in the AI-300 GenAIOps context? A. Replace real user data in dashboards for privacy compliance. B. Create high-quality training or evaluation datasets using LLMs when real labeled data is scarce. C. Generate test cases for Azure Kubernetes deployments. D. Populate Azure Cosmos DB with mock records. Correct answer. B. Create high-quality training or evaluation datasets using LLMs when real labeled data is scarce. Explanation. Synthetic data generation uses large language models to create realistic training examples or evaluation datasets when real labeled data is unavailable, expensive, or privacy restricted. In GenAIOps, this is used to bootstrap fine-tuning datasets, expand evaluation benchmarks, and improve smaller specialized models. AI-300 tests this as a production data strategy. Question 20. What is the correct sequence of steps in a mature MLOps CI/CD pipeline for model updates? A. Deploy right-pointing arrow. Train right-pointing arrow. Evaluate right-pointing arrow. Register. B. Train right-pointing arrow. Register right-pointing arrow. Deploy right-pointing arrow. Monitor. C. Code commit right-pointing arrow. Automated training right-pointing arrow. Evaluation gate right-pointing arrow. Approval right-pointing arrow. Deploy to production right-pointing arrow. Monitor for drift. D. Monitor right-pointing arrow. Train right-pointing arrow. Push to main branch right-pointing arrow. Restart endpoint. Correct answer. C. Code commit right-pointing arrow. Automated training right-pointing arrow. Evaluation gate right-pointing arrow. Approval right-pointing arrow. Deploy to production right-pointing arrow. Monitor for drift. Explanation. A mature MLOps CI/CD pipeline follows this flow. A code or data change triggers automated retraining. The new model is evaluated against quality metrics. If it passes the evaluation gate, it awaits human or automated approval. then it's deployed to production, and continuous monitoring watches for performance degradation and drift. This end-to-end lifecycle is the central concept of the AI-300 exam. That's 20 Operationalizing Microsoft Machine Learning and Generative AI Solutions AI-300 practice questions. How many did you get right? Drop your score in the comments. If you want to keep practicing, the complete Operationalizing Machine Learning and Generative AI Solutions practice question PDF is available from Study 4 Exam. Link is in the description. It includes updated 2026 exam questions across all 5 AI-300 domains, full explanations for every answer, realistic timed mock tests, complete coverage of MLOps, GenAIOps, Azure ML, prompt flow, model drift, CD, and responsible AI observability. This is one of Microsoft's newest certifications and not many prep resources exist yet, so getting ahead now is a real advantage. If this video helped you prepare for the Microsoft Operationalizing Machine Learning and Generative AI Solutions exam, like this video, comment your score and which question surprised you most. Subscribe. I cover Microsoft, AWS, Google, and more certifications every week. The Microsoft Operationalizing Machine Learning and Generative AI Solutions is a challenging exam, but if you understand MLOps pipelines, GenAIOps with Azure AI Foundry, and production monitoring, you are ready for it.